This is a recording for pre-calculus, and this is 4.7 inverse trigonometric functions. And so we've talked about inverses before, and we've talked about inverse functions. And if you remember, for a function to have an inverse function, it has to not only pass the vertical line test, but also the horizontal line test. And so what we're going to do is we're going to evaluate and graph the inverse sine function, and then other inverse trigonometric functions, and then look at compositions of trigonometric functions. And you remember those are kind of the nested function, one function within another. And so we'll start with the inverse sine function, and once we kind of get that down, then the others will be just kind of have relationships to that. And so we know that for a function to have an inverse function, it has to be one-to-one, and that is it passes not only the vertical line test, but the horizontal line test. And here's a picture of a sine function graph. And notice, as we know, it does not pass the horizontal line test because it oscillates between 1 and -1. And so what we want to do is we want to look at an interval in which that function does pass that horizontal line test. And you can see it kind of highlighted there as well. We're used to, and let me just kind of use my little marker, there we go, a minute. We're used to looking at a period of the sine function from the beginning from 0 to 2 pi. If we look at it from there, really we only get to here, which is, let me get rid of some, we only get to pi over 2, and then it starts to repeat itself, so it wouldn't pass that horizontal line test. So what we do is we use this piece, yes, but we back up and use that piece as well. And so if we go from -pi over 2 to +pi over 2, then we have each one of those values represented, and then this does pass, if we just use that yellow piece, it does pass that horizontal line test, because for every value of x, there is exactly one value of y, and for every value of y, there's exactly one x. So that's what we're looking for here, and just we're going to take a piece of the sine function, and then it will have an inverse function. And so some kind of notes we want to make to ourselves. First, maybe you want to just sketch that from -pi over 2, to pi over 2. And just a reminder that, it's 0 and 1 there, but then -1 there. And I will put my 1 and -1 on my axis. And we know that that curve looks kind of like that in that little place. So for the sine function, y equals sine x, we're going to restrict the domain to go from -pi over 2 to pi over 2, that interval, and we'll use braces because that is included. And then our range here just goes from -1 to 1 inclusive. And then if you remember, when we do the inverse, we'll kind of we'll invert those two as we go along. So this just kind of goes through that, and if we use this interval, it's increasing in this interval, it's increasing all the time. It has its full range of values from -1 to 1, and it is 1 to 1. And so it passes the horizontal line test, so it has an inverse as we look at that. So we just said the domain is going to be that. And so then the inverse sine function, just to kind of let you know, that is going to be called the arc sine of x. Y equals the arc sine of x, or y equals sine to the -1 of x. And so we read that the inverse sine of x. So the arc sine of x or the inverse sine of x. And really, we just invert our x and our y-axis as we go through that. And so let's think about our table of values that we can generate all the time. Maybe we haven't done that for a while. I'm just going to have the sine of theta, theta in degrees, and theta in radians. By the way, when we talk about inverse trig functions, we're always going to use radians, but we'll use degrees to kind of make our table here as we go. So we've got 0, 30, 45, 60, and 90. And this is 0, pi over 6, pi over 4, pi over 3, and pi over 2. I'm actually just going to cross that one out because we want it always in radians, and then the sign. So 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. And we're going to look at these values, and when we do that, we're going to now, when we find the inverse, we're going to interchange those two. And so really, the arc sine notation comes from the association of the central angle with its intercepted arc length on the unit circle. The arc sine means the angle or arc whose sine is x as we go. And so now when we kind of look for this inverse, we're going to interchange these. So where if we were looking at y equals sine theta, or I'll call it x, sine x for now, y equals sine x, then these would be the x values and these would be the y values. But now we're going to interchange those two. And so now we're going to have x and the arc sine of x, so the inverse sine of x. So these are really the angle or the arc. So that's what we kind of want to remember as we go. So we're going to kind of do that backwards as well. So the arc sines are 0, pi over 6, pi over 4, pi over 3, and pi over 2. And our x values are 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. So we just interchange those two. And just remember, we are looking for the angle, when we when we are given the sine ratio. So we're given the sine ratio, and then we're going to look at what that angle is that's associated with that. And so that means that we're going from negative pi over 2 to pi over 2. And there's a nice little graph. We'll be graphing that on grid paper just to kind of give ourselves a nice picture of that as we go. And this is the inverse sine or the arc sine as we look at that. So then here's our nice little definition of the inverse sine function. So the inverse sine function is defined by y equals the arc sine of x if and only if the sine of y equals x, where -1 is less than or equal to x, which is less than or equal to 1, and negative pi over 2 is less than or equal to y, which is less than or equal to pi over 2. And the domain of y equals the arc sine of x is -1 to 1 inclusive, and the range is negative pi over 2 to pi over 2 inclusive as well. And so just some little other reminders of things we also know in relationship to this. We know that all students take calculus, and so really think about what quadrants we're in here. We're going from negative pi over 2, and so, you know, if I think of an angle, negative pi over 2 would be this whole quadrant, and positive pi over 2 would be that whole quadrant. So we're using the first and the fourth quadrant. And think about, these are all positive, all the sign is positive. And so we can't keep going that way, because remember, this is the S area, and so the sign is positive there. We need the positive and the negative values. So sign is positive there, and sign is negative there. The nice thing is, whether it's a positive angle or a negative angle, the reference angle is going to be the same as we look at that. And so again, we'll just kind of make our little table one more time. And if we have 0, pi over 6, pi over 4, pi over 3, and pi over 2, we know that the sign of that angle is going to be 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. And then kind of think about a minute. Then for the inverse, we're going to interchange those. So this is now going to be y, and that is going to be x. And think about, if our reference angle is like pi over 3, which I didn't maybe put that in the right spot exactly for pi over 3. If this is a negative pi over 3, the reference angle is still, pi over 3. And so we would pick that square root of 3 over 2, but if it's negative, so then it would be this negative pi over 3. So the arc sine of negative square root of 3 over 2 is equal to pi over 3, negative pi over 3, and the arc sine of square root of 3 over 2 is directly off the table, which is pi over 3. So the nice thing is that we can give many exact values for these, and once we find that reference angle, it's usually either just positive or negative. You will want to remember this little picture. All students take calculus, that we're just using those two quadrants as we go. So now notice our directive is going to be, if possible, we're going to find these values. And so keep in mind, they have to oscillate between negative 1 and 1, and they have to oscillate between negative pi over 2 and pi over 2 as we look at that. And I may be going to kind of grab that copy, and I'll put it on my slide here as I do these. So just a little reminder of some of my sign values as we go. And it says, if possible, find the exact value. And I've been leaving a blank slide. Maybe you've noticed that as I go through these. So here's my method of doing a problem like this. The first thing I do is write that all students take calculus and say, okay, it's going to be in these two quadrants that I'm going to use. Since the arc sine is negative, that means I'm going to eliminate this quadrant, and I know it's going to be down there. And so then I'm going to look at my table of values, and I'm going to say, okay, I want to know when the sine theta is 1/2, sine of theta is 1/2, what would be my reference angle? And so I go over here and sine, I look for 1/2, and that happens at pi over 6. So my reference angle is pi over 6. And since it's down here, that means my answer is going to be down here, and that's pi over 6. So that means that the arc sine of negative 1/2 is negative pi over 6 because we had to go down from there. Take a minute, try the next 3 and see what you get, and then we'll compare our work. Okay, let's see how we did here. So for this one, we're using the first quadrant, and our reference angle from our table of values is pi over 3. So the inverse sine of 3 square root of 3 over 2 is pi over 3 as we look at that. Then for the next one, the inverse sine of 2, again, it's positive, so we're going to be up there. And so we're looking for when is sine theta equal to 2. Well, let's look at our table. Remember that sine theta oscillates between -1 and 1, so it is never 2, so that is not possible. For the arc sine of 1, we're again thinking along the positive, but this one, our reference angle is right there at pi over 2. And so our reference angle is pi over 2. And since it's positive, we want to get the arc sine of 1, which is pi over 2. So keep in mind that sometimes those are not possible, but generally that's what's happening there. Let's take a minute and just sketch a nice picture of the arc sine of x. And I'm going to make a table of values. And I'm just going to do it upside down, kind of. I'll put the angle there, and I'm going to put the sine of the angle there. And I am going to go from negative pi over 2, and then negative pi over 3, negative pi over 4, negative pi over 6, 0, pi over 6, pi over 4, pi over 3, and pi over 2. To get my values that I have there. And I'm going to just start at 0 and go this way and then backwards. So that's 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. This will be negative 1/2, negative square root of 2 over 2, negative square root of 3 over 2, and negative 1. Maybe on a calculator I should get a decimal there. I think this is about negative 0.8. This is about negative 0.7, negative 0.7 and negative, or positive 0.7 and positive 0.8, just to make my graphing go a little easier for myself. And I want to give myself a little bit of leeway here. So I'm going to go from negative 1 here. So negative 0.5 and then 0 and then 0.5 and then 1, just to kind of give myself a little bit of space. And then for pi over 2, again, I'm going to go 2 boxes. So pi over 2 is there, pi over 4 is there, negative pi over 4, and negative pi over 2. So as I kind of plot these as I go on there. And so now let's just kind of put them. And remember, it's sine. This is x, and then this is y, is the angle. And so when x is negative 1, y is negative pi over 2. When this is negative 8, that is pi over 3, negative pi over 3, so it's going to be maybe, I could have maybe done that a little bit differently. We'll say it's going to be, and these two are very close to each other. I maybe am not even going to do those because then they're harder to find. I'll just go right to negative pi over 4. So negative 0.7, 5, negative 0.7 and negative 1 pi over 4. Negative a half is at negative pi over 6. I'm going to ignore that one too, I feel like. I don't have to see that. And then at 0, it's 0. And then at 0.5, it's pi over 6. I will maybe try to put that one on there. And then at 0.7, it's at pi over 4. And then at 1, it's at 2 pi as we go. And so what we get is kind of a curve that looks like that. And so I'll just try to give yourself a good picture of the arc sine graph there as we go. Then we want to look at other, just a second. Just remember that the domain is the closed interval from negative 1 to 1, and the range is the closed interval from negative pi over 2 to pi over 2 as we go. Now we want to look at other inverse trig functions, and we kind of focused on that one. Now we just kind of look at some of those other ones as we go. So cosine, same kind of thing there. We're gonna, if we start at 0, we're at our maximum, and then we kind of go down. If in this one, we're gonna go from 0 to pi. And so kind of think about, all students take calculus. If we use this, cosine will be positive. If we went down that way like we did before, cosine is negative, or still positive. So those are repeated values. We can't use those. So instead, we go over here, and that's where sine is going to be positive, but cosine will be negative. So that kind of gives us that little bit of information there. So our domain is now going to be that we're going to focus on for the inverse is from 0 to pi. So this one's a little trickier because in sine, the reference angle and the angle were the same, but maybe positive or negative. And now we're going to have to kind of get that little bigger angle sometime. So between pi over 2 and pi. So again, the inverse cosine, arc cosine, or cosine to the negative 1. And now let's just kind of, here's all of these, and this is an important little piece here. And then it just talks about the inverse tangent as well. And so if we think about the tangent function, and remember at negative pi over 2 and pi over 2, there are asymptotes. So that means it's not going to include those values. And then we have our 3 key points. So tangent kind of looks like this. And so when we use our interval, we're going to go from negative pi over 2 to pi over 2. And but those endpoints are not counted this time. So all students take calculus. Again, tangent is positive in this first quadrant, and tangent is negative in the second or the fourth quadrant. So those are the two that we're going to use again. So that makes that easy, but then we have to remember that it's undefined. And so just a little note to self. I'm just going to write here arc sine of 5 has no solution, just to remind myself that those have to be between negative 1 and 1. And so the arc sine has the domain from negative 1 to 1, the range from negative pi over 2 to pi over 2. And I usually go with this, all students take calculus. And so I'm using those two quadrants. For the arc cosine, it goes from negative 1 to 1 also, but this one, all students take calculus. This time we're using these two quadrants. So this one is a little trickier because when we're in that S quadrant, when we have negatives, we have to kind of find that angle from the reference angle. And then the last one, the arc tangent, It does go from negative infinity to infinity. I didn't say that because, but it does. And that's going to be the domain now. And the range is not including the endpoints for tangent, not including endpoints for tangent. Um, so because those are asymptotes and it's undefined. And then we will say though, and let me white out this page number, sorry. We will say though that when we use this all students take calculus, we again use the first and fourth quadrants. So arcsine and arctangent are easier because the reference angle and the angle are the same. Arc cosine, we just have to be cautious of that quadrant as we look at it. Then next we have some graphs of the three inverses. If you want to pause this and just give yourself a little sketch of those, that might be a good idea. And noticing kind of the way those axes are labeled so that you're careful with that. So pause this if you want to. I'm moving on. Then you might take a moment and just generate the table so that you have that again as you're looking at that, and then all students take calculus, and then those quadrant angles. So moving on, here's my table that I generated, and those values as well. So let's move on to number 3, and we want to find exact values of these trig functions as we go. So let's kind of put our table on here in the corner as well so that we have access to that, and you've already drawn it. Okay, so I put a nice little graphic of my table there. I crossed out the degrees because I'm only using radians when I go through these. And now let's kind of look at what we get. So we want the arc cosine of the square root of 2 over 2. So first thing I would do is this little all students take calculus. So it's arc cosine. So it's not going to use those bottom two. It's going to use these two. It is positive square root of 2 over 2. So we're not going to use that one. It's going to be this first quadrant. Then we find a reference angle on the table, and our reference angle for cosine to be square root of 2 over 2, our reference angle is pi over 4. And so our reference angle is pi over 4. Since it's positive, that is pi over 4. So that's the answer for the arc cosine of that one. Take a minute and do B, C, and D, and we'll compare those. And if I'll actually go ahead and do all of them, I want to go over E and F. So I'll show my work for B, C, and D, and then I'll just go over E and F. And then there's actually a G as well. And so I'll go over all of those. So take a moment, pause this if you want to try B through F, and then we'll move on with E and F after I show the work for these. So let me briefly go over A, or B, C, and D. Oops, sorry. And so we have the arctangent of 0. Our reference angle there is 0, and so that is just equal to 0. For the next one, the inverse tangent of -1, we're still in that first and fourth quadrant to look at those. And when we look for our reference angle of 1, that happens at pi over 4. So since we're in that negative quadrant, it'll be negative pi over 4. For letter D, we have all students take calculus, so we're in that first two quadrants. -1 is the angle, or the ratio, and so our reference angle for 1 is 0. Well, that means we're at that point, -1, 0 with cosine and sine, so that is at pi, if we kind of look at that. And that maybe leads us to this next type of problem. And I have been just kind of moving these little circles off of here after I'm done using them. So now let's look at what happens in this next one. And we know that we're using all students take calculus and we're using our cosine, so we're using these first two quadrants. It's negative this time, so we're not in that quadrant. We're over here in the second quadrant. So we do the same thing, find our reference angle based on the square root of 3 over 2. So it's cosine, square root of 3 over 2 is right there. And the reference angle is pi over 6. Pi over 6. But now, when we kind of think about that, we have pi over 6 is the reference angle right there. But the angle that we want is this angle that's right here. And so what is that angle? That angle is, we'll say pi minus pi over 6. So our actual angle is pi minus pi over 6. And so that's like 6 pi over 6 minus pi over 6. So that is 5 pi over 6. So this one is 5 pi over 6. So if you had pi over 6, it's the right reference angle, but it isn't the actual answer for that one as we go. The next one is arc cosine of 2. Do you recognize nothing? It has to oscillate between -1 and 1, so there's no solution there. If you haven't already tried this last one, maybe you couldn't see it. It's the arc sine of -1/2. If you want to try that, go ahead, and then I'll go over that one as well. So let's see how you did on this one. Oh, sorry. And so there we go. For this one, we're using the first and fourth quadrants, and our reference angle is pi over 6. And since it's -1/2, we're going to be in that fourth quadrant. And so the reference angle is pi over 6. The actual angle is -pi over 6. Hopefully you did well on that. Now, keep in mind, inverse trig functions are always in radians. Take your calculator and see if you can get some decimal answers for these. I just wrote long decimals, so whatever you get will be fine. And we'll check that on the next recording. Have a great rest of your day.